Hello, I'm Joseph Kasser, and welcome to this podcast where the AI team does a deep dive into some application of systems thinking.
I want you to picture a very specific kind of pain.
Oh, I think I know where this is going.
You probably do. So you were in a conference room. It is the critical design review. The air conditioning is humming way too loud. The coffee is completely stale, and you have this massive pit in your stomach.
Yeah, the classic high-stakes engineering environment. We have all been there.
Exactly. And you have spent the last 6 months on this model. I mean, it is a masterpiece.
A real work of art.
Right. You have got your blocks aligned, your ports are connected perfectly, you've traced every single requirement down to a function. It's basically a cathedral of logic built in SysML.
And it is literally the thing you were hired to build.
Right, exactly. So you put it up on the projector and you're feeling pretty good about it. And the chief engineer looks at it, squints a little, nods politely, and then just says, "That's nice." Now, can someone pull up the spreadsheet so we can actually figure out if this thing's going to work?
Oof. Yeah, that just hurts hearing it described out loud.
It's the spreadsheet of truth versus the model of good intentions.
That is exactly what it is.
And that brutal reality brings us to today's deep dive. We are looking at a provocative paper that explains exactly why that moment happens and why it is really tearing the soul out of systems engineering as a discipline.
Yeah, we're digging into a paper from February 2026. It's called The Collapse of MBSE and the Collateral Damage to Systems Engineering, written by Art Villanueva. And I have to say right up front, this isn't just a technical critique.
Oh, no.
It really reads like a wake-up call for the whole industry.
It really does. Because the premise here isn't that the software tools are buggy or broken. The premise is that model-based systems engineering, or MBSE, has effectively become glorified paperwork.
Right.
And that by focusing so heavily on these models that nobody actually uses to make decisions, we are actually destroying the reputation of systems engineers.
That is the collateral damage part of the title. It is a really heavy claim to make.
So our mission for this deep dive is to figure out if that's true and to unpack the massive difference between documenting a system and actually engineering one.
And that distinction really is everything.
So let's start with the symptom described in the paper.
Yeah.
Because, if you look at the industry from a distance, or maybe from the perspective of a VP sitting in a corner office, everything looks great.
Oh, absolutely. I mean, if you just look at the management dashboards, everything is green.
Right.
Companies are pouring unbelievable amounts of money into these tools. They are running massive training programs. They have governance boards set up. The models themselves are internally consistent.
They pass all the automated checks.
Exactly. They pass all the reviews, and everyone's favorite thing, the traceability matrices are 100% complete.
But the author points out this massive disconnect. It is a form of what they call compliance theater.
Compliance theater. Yeah, think of it like this. You buy an expensive gym membership, you buy the fancy workout clothes, you get up early, drive to the gym every morning, and you swipe your card at the front desk.
Okay.
But then you just go sit in the lobby, drink a smoothie, and scroll through your phone.
Okay, wow. I feel a little personally attacked by that analogy.
Right. But if you look at your bank statement or your attendance record at the front desk, you are officially a gym goer.
But you aren't actually getting any stronger.
No. And that is the state of modern MBSE, according to this paper. We have the tools, we bought the expensive licenses, we made all the diagrams, but we aren't lifting the actual weight.
So in this metaphor, lifting the weight is making the actual engineering decisions.
Exactly. The paper highlights that despite all this massive effort, the model is rarely the decisive input.
Yeah.
When push comes to shove, when you actually have to decide between two different thrusters or figure out if a battery pack is going to overheat, the team doesn't gather around the SysML diagram.
They go straight back to the simulations.
Yes. They go to the prototypes or that spreadsheet of truth we mentioned earlier.
So the model isn't driving the car. It's just sitting in the passenger seat taking notes.
Pretty much. It's usually updated after the decision has already been made. It becomes a historical record. It's like, okay, we decided to use the lithium-ion battery in the meeting. Now somebody go update the model so it matches reality.
That feels like digital archaeology. You are just digging up what already happened and putting it in a glass display case.
That is a perfect way to put it. And it creates this lingering feeling that modeling is totally disconnected from real work.
Right.
It isn't that the tools are broken. They work exactly as the software vendors say they should, but the value proposition just feels thin. And the author diagnoses this as a fundamental category error.
Okay, let's unpack category error. That sounds a bit philosophical. What categories are we actually confusing here?
We are conflating systems engineering with MBSE, and this is crucial for everyone listening to understand they're not the same thing.
But I feel like if you look at job descriptions today, they're used completely interchangeably.
They are, and that is exactly the problem. Systems engineering is the discipline. It is a cognitive way of reasoning about complex problems.
Like framing trade-offs and managing risk.
Yes. Defining interfaces, understanding the system as a whole, it is a deeply cognitive and social activity.
Which you could technically do on a whiteboard.
You could do it on the back of a napkin in a diner. You could do it in a Word doc. Historically, systems engineers just used whatever tool worked best to solve the puzzle in front of them.
So what is MBSE then, in this context?
MBSE is just a technique. It is a specific set of practices, usually using a language like SysML, to represent that information. Ideally, it is supposed to help you reason. But somewhere along the way, doing systems engineering just morphed into producing SysML models.
I see. So the perception becomes, if you aren't clicking around in the software tool, you aren't doing the job.
That is the trap. The map has completely replaced the territory, and the consequence of that is severe. When those models fail to influence the big decisions, people don't just say the model isn't useful.
They say systems engineering is useless.
Exactly. They say the whole discipline is just overhead.
Which perfectly leads us to the absolute core concept of this source material, the load-bearing test. I absolutely love this mental image because it really cuts through all the corporate noise.
It clarifies everything. The author asks a very simple, very brutal question. What breaks if you remove this practice?
Okay, let's run the test for our listeners. Walk us through a couple of examples.
Take structural analysis for a bridge. You have a complex mathematical model that calculates all the loads on the steel beams. If you delete that analysis, if you just remove the math entirely, you cannot build the bridge.
Right. Or if you try, it falls down immediately.
Exactly. Same thing with software code. If you delete the C++ code for an airplane's flight controller, the plane does not fly, period. Those are load-bearing practices. The project cannot physically function without them.
Okay, now be honest. What actually happens if you delete the MBSE artifacts? What happens if I go into the server tonight and delete the entire SysML model?
Well, the project manager might yell at you.
Sure.
The audit team might flag you for noncompliance. But the system itself, the system is still going to be built. The plane probably still flies just fine.
Wow, that is pretty damning.
It really is. Because the engineers will just email each other the spreadsheets they were already using anyway. Interfaces will still get negotiated in conference rooms. The designs will be analyzed in Python scripts.
So the loss of the model is annoying, but not fatal.
Right. You lose some traceability, and coordination definitely gets harder, but the system doesn't collapse.
Which proves that MBSE, at least as it's commonly practiced today, is not actually carrying the engineering load. It is basically decorative.
It is the paint on the walls, not the wooden studs holding up the roof.
But wait, I have to ask why. We have incredibly smart people working on these projects. We have incredibly expensive software. Why is the model just paint? Why can't it do the heavy lifting?
It comes down to a fundamental mismatch between the tools we have and the expectations we placed on them. The paper points out that SysML version 1, which is the language most of the industry still runs on, was explicitly designed to be descriptive.
Descriptive meaning it is just drawing a picture.
Essentially, yes. Think of it like this. You can draw a very accurate, beautiful picture of a calculator on a piece of paper. You can draw all the buttons, the little screen, the solar panel. It looks exactly like a real calculator.
But if I try to press the buttons on the paper,
nothing happens. It cannot do math. That is SysML version 1. It describes the structure. This box connects to that box over there, but it doesn't have standard execution semantics.
Interesting.
It doesn't have a concept of time. It doesn't have built-in math for handling uncertainty.
So you can't ask the diagram, what is the probability this component fails?
No. You can't ask it, what happens if a massive voltage spike hits this specific wire? The model just stares blankly back at you. It doesn't know Ohm's law, it doesn't know physics.
But the industry expected it to do all of that anyway.
Yes. As MBSE grew in popularity, we started treating these descriptive models as if they were analytical ones. We wanted them to predict behavior. But because the tool couldn't actually do the math, we just ended up drawing more and more complex boxes to describe the math we wish it could do.
And the workflow friction seems like a huge factor here too. The paper mentions that because these tools are so incredibly complex to use, you basically have to stop working to go do modeling.
Yes, it requires what the author calls focused interaction. You cannot easily sketch out a SysML diagram while you are in the middle of a heated, fast-paced debate about thermal loads. It is just too clunky.
So modeling becomes this separate, isolated activity.
Exactly. It gets done before the review to make the slides look good or after the decision to update the record. It is rarely done during the messy, chaotic process of actual engineering thinking.
And this brings us to the collateral damage. This is the part of the paper that I think will really sting for a lot of our listeners. They talk about the draftsman problem.
It's a historical analogy, but it fits the current situation perfectly. Think about the old-school architectural draftsmen. They didn't design the building themselves. They took the architect's rough sketches and formalized them into clean blueprints.
They recorded the design, but they didn't make the decisions.
And that is exactly what is happening to systems engineers today.
In a lot of organizations, yeah.
As the actual decision-making power moves to the people who can predict the future, the software teams, the test engineers, the domain specialists running their high-fidelity spreadsheets, the systems engineer is left just trailing behind, recording those decisions in the model.
The paper calls this a loss of epistemic authority, which I think is just a fancy academic way of saying, if you can't tell me what is going to happen, I'm not going to bother asking you for advice.
That's spot on. Epistemic authority basically means, do you actually know what you were talking about? If I ask the thermal engineer, will this part melt? They say, yes, it melts at 400 degrees. They have authority because their tool gives them a definitive answer.
But if I ask the systems engineer, will this melt?
They might just say, let me check the traceability matrix to see if we have a requirement documented regarding melting.
And that is exactly when you stop inviting them to the critical meetings.
Precisely. You become the librarian of the project. You organize the information, which is helpful, but you don't generate the engineering insight. And that is incredibly dangerous for the discipline because systems engineering is supposed to be the technical conscience of the whole project.
And I imagine some organizations actually lean into this dynamic without realizing it.
Oh, they do. They hire dedicated modelers. The paper describes this massive shift where you have people whose entire job is just to translate decisions made by other engineers into formal diagrams.
Which just reinforces the bias that SE is all about formatting and compliance.
Right. It confirms the worst stereotypes about systems engineering being pure overhead.
Now, I know some listeners are probably screaming at their speakers right now. But wait, SysML version 2 is out. We have AI now. Surely new technology fixes this whole problem.
And the paper addresses that directly, actually. It acknowledges that SysML v2 is a significant technical improvement. It has much better semantics. It integrates way better via APIs.
And you've got agentic AI that can automate a lot of that tedious consistency checking.
Yes. So the technology is definitely improving.
So, problem solved. We just sit back and wait for the enterprise software update.
Not quite. The author argues that while these technologies raise the technical ceiling, they do not fix the underlying category error.
How so?
Well, if you use an advanced AI to generate your compliance documentation much faster, you are still just generating documentation. You still aren't doing engineering.
That makes perfect sense. A faster typewriter doesn't automatically write a better novel.
Exactly. If your underlying process is still record the decision after it's made, then AI just makes you a much faster historian. It doesn't magically make you a better engineer.
And there's this concept the paper introduces called calm technology. I really like this phrasing when I read it.
It is a great concept. Most successful technology recedes into the background. It lets you focus purely on the task at hand.
Like a good pen.
Right. But MBSE tools are not calm. They constantly demand your attention. You have to fight the tool itself just to get the diagram to look right. And even with AI, if your primary focus is on maintaining the artifact rather than solving the engineering problem, you haven't restored the load-bearing nature of the discipline.
So better representation does not equal analytical reasoning.
That is the big takeaway right there. You cannot code your way out of a fundamental process problem.
Okay, so we've diagnosed the illness here. The patient's systems engineering is stuck documenting instead of deciding. What is the cure? The paper outlines a practical path forward.
It starts with something they call scope discipline. We need to stop asking MBSE tools to do things they were simply never designed for.
So stop trying to make SysML do the math.
Correct. The paper proposes a clean split. MBSE is for representation, coordination, and traceability. It provides the map. But actual analysis using MATLAB Python spreadsheets, that provides the terrain.
The map versus the terrain. I like that a lot. Break that down for us.
Well, the map is not the territory. The MBSE model shows you where things are, how they connect to each other, where the system boundaries are. It is genuinely excellent for coordination questions like, does the pipe from the fuel tank actually connect to the right port on the engine?
But it doesn't tell you how fast the fuel is flowing or if the pipe is going to burst under pressure.
Exactly. That is the terrain. That is the analysis. The solution is to let the terrain tools do the heavy lifting they are good at. The model shouldn't try to contain the analysis inside itself. It should just reference it.
So the model acts more like a pointer.
Ideally, yes. The model says, here's the specific requirement for thrust, and click this link right here to see the MATLAB script that actually proves we met it. It doesn't try to recreate the entire MATLAB simulation inside a SysML block.
That seems so obvious when you say it out loud, but I bet it is surprisingly hard to enforce in a big company.
It requires really strong management. The paper suggests explicitly defining MBSE as a coordination layer and absolutely not as a simulation environment.
And what about the people aspect? We talked about the draftsman problem. Does the paper say we should just fire all the dedicated modelers?
No, not at all, but it redefines the relationship. And this is crucial. It says that engineers own the decisions, the trade-offs, and the risks. Modelers, if you have them, maintain the coherence and fidelity of the representation.
So the modeler is essentially a really high-functioning coordinator.
Yes, but they are not surrogate engineers. You do not hand off the engineering thinking to the modeler. You hand off the representation of that thinking to the modeler. The engineer still has to own the why.
And the paper suggests we should completely change how we measure success, too. Because right now, we measure success by asking, did you finish the model?
Right, which is a terrible metric. Instead, we should measure coordination quality. Did the model actually reduce miscommunication between teams? Did it help us spot an interface conflict 3 months earlier than we would have otherwise?
That shifts the whole value proposition from, look at this really cool diagram, to, we didn't crash the satellite because the model showed us the wires were crossed.
Exactly, because that is load-bearing. Even if the model didn't do the complex math itself, if it prevented a massive coordination failure, it is carrying real weight for the project.
That feels like a much healthier place to be. It respects the tool for what it actually is, without pretending it is some magic crystal ball.
It is about being honest with ourselves. Systems engineering isn't dead, but we tried to replace engineering judgment with descriptive pictures, and that experiment largely failed.
So to wrap this whole deep dive up, the summary really seems to be, stop treating the model as the end goal. The goal is a working, safe system. The model is just one tool to help us get there.
That is the gist of it. We desperately need to reassert systems engineering as a decision-making function. The software tools are just support infrastructure.
The paper ends with a really provocative question that I think every single listener out there should ask themselves about their current project. And I want everyone listening to really think about their honest answer to this.
Yeah, it asks, did the model change the decision or merely record it?
That cuts deep.
It really does. If your honest answer is it just recorded it, then as we said earlier, you aren't really doing MBSE. You are doing digital archaeology.
Digging up the past and putting it in a display case.
And that is perfectly fine if you are a museum curator. But if you are trying to build a complex system, you need to be in the driver's seat, not the archive room.
Well, there you have it. A real call to arms for systems engineers everywhere. Get back to being load-bearing. Use the tools, but do not let the tools use you.
I couldn't have said it better myself.
Thanks for joining us for this deep dive. Go check your models, ask the hard questions, and we will catch you on the next one.
I hope you enjoyed today's deep dive. Why not take a moment and join the discussion in the LinkedIn group Tackling Complex Problems. Take care.